Hello everyone. I want to welcome you to our next but relatively short section on new assignment operators, new Java operators. We're going to look into compound operators and we're going to look into unary operators in this short section. And first, let's start with compound operators. Compound operators are also known as shorthand operators. These operators are called compound because they combine assignment operator with arithmetic operators, right? So this is our assignment operator equal to, and the following are our arithmetic operators: addition, subtraction, multiplication, division, and modulus, correct? So what happens is there might be certain cases where we want to take our variable of any type. Usually we're talking about primitive variables, right? And usually we're talking about numeric variables. We want to take our variable and just add, for example, 2 to its current value and update our variable. You see? So one more time, we take a variable, add 2 to it, and go back and reassign this result into our initial variable. So basically, let's say I'm driving 54 miles an hour, mile per hour, and I want to just increase my speed from 54 to, let's say, 60 miles per hour, my speed limit. So what I want to do, I want to say 54 plus 6. And I want to say this 60 is going to be equal to my initial variable, my current speed now. So what I do is I say speed is equal to speed plus 6. Now, Java provides the combination of this equal to and plus and tells us that you don't have to write this every single time. So your speed variable does not have to repeat itself. This is redundant. So what you can do instead is you can do this: speed plus equal to 6. What happens with plus equal to is this operation above is being converted into this shortened operation. That's why compound operations that combine assignment with arithmetic operators are also called shorthand operators, because they just shortened the right-hand side of the operation. What this stands for is, when Java sees this, Java comes here, speed plus, okay, equal to. So take the value of speed, add 6 to it, reassign it back to the speed. So after this, our speed is going to be equal to 60 if it was 54 before. So there are, as we have 5 arithmetic operators in Java, there are going to be 5 compound operators that we will use in our day-to-day programming. We might use in our day-to-day programming. There are 4 or 5 additional compound operators. Those are to take care of operations on a bit level, on bitwise level. We are not going to look into them. You can research them online, but today we will look at plus equal to, add and assign, minus equal to, subtract and assign, multiply equal to, you multiply and assign, divide equal to, divide and assign, and modulus equal to. Find the remainder and assign the remainder. Okay, let's see an example of these in action. To do so, let's create a new section, because we moved on to new section today. Congratulations. So we're going to create a new package. We're going to call it section 3_4. Within this new package, we're going to create a new class. We're going to call it compound demo. Since we gave up an example of speed increase, let's do this. Let's declare our main method, leave it blank. We're going to create a new method. We're going to call it speed adjuster method. Uses compound operators to adjust our current speed to the speed limit. Okay, now let's call this public static void limit 55, because int. Now it accepts a int parameter. We call it limit 55 because when we call this limit 55 method, it's going to adjust our speed to the limit of 55 miles per hour. So here, we're gonna combine compound operators with if-else conditions, if-else branching. So before we do so, let's think about our test cases, right? Our case scenarios, test values. If my vehicle is driving at 50 miles per hour, I will need to add 5 miles per hour and say that the speed is current speed is 55 miles per hour. If my vehicle is driving at, let's say, 60 miles per hour, I need to subtract 5 miles per hour so I get my car's speed back to 55 miles per hour. If my vehicle excuse me, if my vehicle is driving at 25 miles per hour, which is 2 times less than 55 miles per hour, I need to multiply it by 2 and say that current speed is 50 miles per hour. If my vehicle is driving at, oh my God, I don't want to go to this case where I was going to say my vehicle is driving at 100 miles per hour, I want to reduce it by 2, but let's say we have that. Let's say we're driving a very sportive vehicle and we didn't know the speed limit and we accidentally are driving 100 miles an hour, and in that case our limit 55 should limit our speed and decrease it by 2 times. And let's say in all the other cases we're going to use modulus operator, and we're going to use modulus operator in a different method. We'll look into that later on. So we have these 4 compound operators. So let's look at these cases. My first if condition, if my speed is my number, or actually let's call it speed. Instead of, we can call our parameters, we can name them as we wish. So we're going to name this parameter speed. So we're going to say if speed is equal to 50. Open our statement. Speed, add to it and equal to 5. Print out speed. Or let's add a message, current speed. So as we always say, this complete small pieces of code, test them. In this piece of code, we created a if condition for first test value. If my speed is 50 miles per hour, I will increase my speed by 5 and I will print out my current speed. So let's call this method and pass this test value in it. Limit 55, and let's say my current speed is 50. When I run this method, I will get output current speed 55. So if you want to see the values of like the change in values, let's create actually int current speed, or let's call it int initial speed is equal to 50. Instead of passing just the number here, we're going to pass the variable name here, initial speed, so that you know. And before we pass it and change it, we're going to print this out to the console by message initial speed and add concatenate initial speed. So just to demonstrate that our initial speed was 50, we're going to print it out. Then when we passed in the initial speed value into our method as an argument, our method changed the value and printed it out accordingly. So let's do that, minimize our comments, and look at what happened. This first initial speed is displayed from line 11, where we're taking our initial speed and printing it out. Then we're passing that initial speed value into our method called limit 55, and from that method, after this compound operation, we get current speed 55 miles per hour. Great. Let's code for other cases, test cases that we have. What if we have 60 miles per hour? What if we have our vehicle driving at 60 miles per hour? Let's create our else if branch. Else if speed is equal to 60, decrease the speed by 5, decrease and reassign it to 5. So compound operation of subtraction and reassignment, system out print line, current speed plus speed. And we're gonna see that our initial speed was 60. Let's add a value here, test value here. It's gonna print the initial speed was 60. Then we're gonna see the output speed, the current speed is 55 miles per hour. Run it. What happened is when we pass 60 as a value to our method here, when we start executing our method block, we looked at the if statement. Speed, is it equal to 50? The answer is no, so this is false. Oh, we have another branch. Is speed equal to 60? The answer is yes. So let's execute this block here. Let's decrease the speed by 5 and assign it back to it, and let's print out the speed. Great. Third case scenario, our speed is 25 miles per hour. We're driving very slow, so we need to increase our speed immediately at least 2 times to a case where it is at least 50 miles per hour. 25. So if our speed is equal to 25, speed multiply and assign by 2. Okay, so multiply it by 2 and assign it back. So if it's 25, we're going to multiply it by 2, we're going to get 50, and we're going to assign it back. So if you print out current speed, then you will see that it was initially 25 miles per hour. Now we're at 50. So we can call this method again, and we can say that since it's 50, increase it, but we will see how to do that in our future classes. In this case, this is just a simple demo of our increment, our shorthand operators. And the last case, if our speed is 100 miles per hour, and actually let's do this, is if our speed is greater than or equal to 100 miles per hour, definitely take the speed divided by 2 and assign it back to it and printed it out. So current speed. Let's watch our spaces because it's gonna look good. 100 miles per hour, it was initial speed. And now we're at 50. If we're driving at 110 miles per hour, since we have greater than or equal to assignment here, and you're at 55. So basically, this is the demonstration of how you can use shorthand operators. Now, the last but not the least, in all the other cases, else we don't need any, we don't need any condition, because else means all the other cases. What we're going to do is we are going to find the modulus remainder of the speed with our limit. So we're gonna create a small local variable. We're gonna call it difference is equal to, you can do this, 55 is our limit minus our current speed, right? Now, the only thing is we need this difference to be a positive number. However, let's actually keep it the way it is. So 55 minus the speed. In that case, what we're going to do, we're just gonna say, take this difference and add it to our speed. The reason is, if the difference is, if for example we're driving higher than 55 miles per hour, we're gonna get a negative value, right? So if we add negative value to our current speed, it's gonna get back to our speed limit. If we're driving lower than 55 miles per hour, what will happen is, let's say we're driving 51 miles per hour, we're gonna get positive 4, and since our current speed is 51, add 4 to it, you're gonna get your speed that you wanted. So what we're gonna do is we're gonna say speed plus equal to difference. Run this case. Oh, I'm sorry. Current speed and add the speed. Now, we tested for 110, we tested for 100, we tested for 25, 60, 50. Let's throw in a random number. Let's test for 49, right? How about that? Let's test for 49. Run this case. Our current speed is 55. So you might probably ask yourself, why did we need all these? Because we could have just coded simply this and achieved our result that our system always limits us and brings us to 55. These all were the demo of how you can use these compound operators. Down the road, when we'll start creating complex codes, you will need these compound operators to speed coding, to increase your efficiency, and to clear your source code. So keep your source code clean. So this is excuse me, this is much better than writing one variable name twice. That's not going to look professional. This is going to help you out, and this is going to increase your efficiency. Well, thank you very much for your time. In the next video, we will look into unary operators and how we can use them. Thank you. I'll see you then.